Hi everyone, this is the first lesson in the organic chemistry topic. We're going to cover how coal and crude oil are formed, we're going to look at what a hydrocarbon molecule is, and we're also going to look at some of the properties of those hydrocarbon molecules. Organic chemistry is all about molecules based on carbon, and these molecules often come from living things or once living things like crude oil and coal. And for your exam, you need to know how crude oil and coal were formed. There's many similarities between the two, but there's also some differences. So first of all, crude oil was formed from plankton that lived in the sea millions of years ago, and these are tiny microscopic creatures. When these millions of plankton died, they fell on the seabed and got covered by layers of sediment and mud. The layers of sediment and mud kept the oxygen out and stopped them rotting away completely. And then heat and pressure deep within the earth over millions of years turned that plankton into crude oil. Coal is also a fossil fuel because that is made from things that were living millions of years ago, but in this case it was made from trees. And those trees were taking in carbon dioxide when they were photosynthesizing millions of years ago, and then when they died they fell into swamps. And once again they got covered by layers of sediment and mud, and heat and pressure turned those once living trees into coal. The molecules found in crude oil are hydrocarbon molecules. That means they're only made of hydrogen and carbon atoms joined together and nothing else. So I'll show you what I mean with these mods. So the black beads are meant to be the carbon atoms and the white ones represent the hydrogen atoms. So we can see here a small hydrocarbon molecule made from carbon and hydrogen atoms. This one's also made from just carbon and hydrogen atoms, nothing else, and so is this one. And you'll see they're different lengths. And in crude oil, it's a mixture of hydrocarbons that vary in length. So the smallest hydrocarbon might be like this one, methane, that's only got one carbon atom in the molecule. The longest hydrocarbon in crude oil can be over 100 carbon atoms long. These mods, along with all the other equipment I'm going to be using in today's video, are available from Philip Harris, and there's a link to the Philip Harris website in the description below my video. We're now going to have a look at the properties of the different length hydrocarbon molecules that you find in crude oil. So I've got here 4 beakers of hydrocarbons with the shortest hydrocarbons on the left and the longer hydrocarbons on the right. And first of all, we notice a difference in colour. The shorter hydrocarbons are lighter in colour, and as they get gradually longer, the hydrocarbons get darker in colour. The next property we can talk about is viscosity. And that's a measure of how runny or how kind of treacly the liquid is. So the short hydrocarbons are very runny. We say they've got a low viscosity. Whereas the longer hydrocarbons are much thicker and more treacly. We say they're more viscous, or they've got a high viscosity. We also notice that as the hydrocarbon molecules get longer, they get a higher boiling point. So the short hydrocarbons have a low boiling point and the long hydrocarbons have a high boiling point. And that's because if we imagine these long hydrocarbon molecules, we can see there's more intermolecular forces between those molecules. Whereas with the short hydrocarbons, there's less intermolecular forces, and therefore they have a lower boiling point if they're a shorter molecule. I'm now going to pipette a small amount of the shortest hydrocarbons onto a watch glass to see how easily it sets on fire. In other words, to see how flammable it is. You'll notice I've moved the beaker out of the way before I try and set fire to the small amount on the watch glass. That's for safety reasons. So let's see how easy it is to set fire to the shortest hydrocarbons. And straight away, that's actually on fire. It's burning with such a clean flame that you might not be able to notice it, but if I put the wooden splint back in there, it sets it on fire again. And one more time, there we go, we can see that it is actually on fire even though it's burning very cleanly. I'll now try and set fire to the slightly longer hydrocarbon. We can tell it's slightly longer by the colour of it. This time it's really quite difficult to get it to set on fire. In fact, it only wants to burn when some of it is soaked onto the wooden splint, and then it's burning with quite a smoky flame. I'll now try and burn the longest hydrocarbon molecule to see how flammable that one is. So this one's really not flammable at all. In fact, it's actually put the flame out. So we can see as the hydrocarbon molecules get longer, they become less flammable. The more flammable hydrocarbons are the shorter ones, so they tend to make good fuels. Let's summarise the properties of hydrocarbon molecules. The short hydrocarbon molecules are lighter in colour, they have a lower boiling point, they are less viscous, in other words they're runnier liquids, and they're more flammable. The longer hydrocarbon molecules are darker in colour, they have a higher boiling point, they're more viscous, and they're less flammable. Now it's sometimes good to organise your knowledge into tables like this because it's very easy then to test yourself when you're revising. You simply get a piece of blank paper, cover up the properties of the molecules, and as you move down the page, can you remember all those different properties about the short and long hydrocarbon molecules? Remember to give the video a like if you found it useful, and don't forget to subscribe to my channel so you don't miss out on future videos. Thank you for watching.